Here in Mission Control Houston, things remain relatively calm now 5 days, 5 hours since Orion's liftoff aboard the Space Launch System from the Kennedy Space Center in Florida. The next major milestone that we're tracking ahead of today's burn will be a go-no-go poll where Flight Director Rick LeBrode will poll the team here in Mission Control on key systems required for the upcoming burn. On your screen, you're continuing to get a live view of the moon taken from one of the Solar Array Wing, or SAW, cameras on board the Orion spacecraft. Orion is traveling at 1,248 miles per hour and is only 2,600 miles away from the moon at this time. Again, upon closest approach, Orion will be about 80 miles off of the surface of the moon. Now, we will be in that anticipated and expected loss of signal during that closest approach. However, we do expect to regain signal with Orion just about 2 minutes after the closest approach, where we will regain communications with the vehicle. At this time, we're 15 minutes away from the planned go-no-go poll, where Flight Director Rick LeBrode will poll the team here in Mission Control ahead of today's upcoming outbound-powered flyby burn. Orion is now 2,000 miles away from the moon, continuing to close in on its destination for this particular burn, the backside of the moon. The outbound powered flyby is the goal of today's operation. This outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical orbit around the moon, which will last about 6 days. Following this, Orion will perform a similar maneuver called the return-powered flyby, which will put it on the trajectory to return back to Earth ahead of a splashdown in the Pacific Ocean on December 11th. Now, the first time a NASA vehicle flew behind the backside of the moon with crew on board was first done during Apollo 8. And here you are looking at a live view of the Orion spacecraft from the solar array wing with the moon in the distance of the screen, the Earth in the distant frame of the screen, and the moon up close. Again, we are now less than 2,000 miles away from the moon, but over 200,000 miles away from planet Earth. Orion started its journey 5 days ago from the Kennedy Space Center in Florida, where it launched aboard the Space Launch System. Orion has been traveling to the moon ever since, performing checkouts of its systems, as this is an uncrewed test flight. It's critical that NASA tests out the hardware and systems aboard Orion ahead of flying a crew on board Artemis II. The solar array wing or SAW camera on board the Orion spacecraft, which is 5 days into its mission, just 1,400 miles away from the moon. We'll continue to see the moon grow larger in the frame here in the next couple of minutes before we do lose signal from Orion as it flies behind the moon. Now you are seeing the Earth, you are seeing home, you are seeing yourself in that image right there, as Orion is 232,000 miles away from planet Earth. Now less than 4 minutes away from our expected loss of signal as Orion travels behind the moon. While behind the moon, Orion will perform the outbound powered flyby, which the team here in Mission Control is ready for. Flight Director Rick LeBrode pulled the team. Everyone is pulling go. Everything still on track for the outbound powered flyby burn, now 20 minutes away. This outbound powered flyby will send Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for one long elliptical around the moon, which will last about 6 days. Now, this is different than what was done during the Apollo program, when the spacecraft orbited much closer to the moon. Now, this orbit is called distant due to the high altitude from the moon. It's about 40,000 miles past the moon in its orbit. This is actually 30,000 miles farther than the previous record set during Apollo 13 and will be the farthest in space any spacecraft built for humans will have ever flown. This orbit is called retrograde because Orion will travel around the moon opposite the direction the moon travels around Earth. Distant retrograde orbit provides a highly stable orbit where little fuel is required to stay for an extended trip in deep space and allows the opportunity to put Orion's systems to the test in an environment far from Earth. We are now less than 2 minutes away from our anticipated loss of signal as Orion travels behind the moon. As we continue to get live views here for the next minute or so, we will potentially see the Earth start to go just behind the moon as Orion travels behind the moon. We will not have Earth views, of course, because the moon will be blocking the Orion spacecraft. However, we do anticipate an acquisition of signal at 6:59 a.m. Central. It's about a 34-minute loss of signal, at which point we hope to regain communications with the spacecraft.